Welcome, ladies and gentlemen, to this video lecture. So in our previous lecture we introduced the definition of limits that tend to infinity at infinity. Let's take a look at this example. So we want to prove, using the definition, that this limit as x tends to infinity of x squared over x plus 1 is equal to plus infinity. So we want to use the definition. So first thing we do is we write out exactly what we have to prove. So what do we have to prove? And now all we do is we just expand the definition of what this statement means. So this means for every e greater than 0, there exists an m greater than 0, so that if x is bigger than m, then f of x is bigger than e. So if we think about this, our function does something like that, and what we're saying is for every e, doesn't matter where we put it on the y-axis, as long as it's positive, we should be able to find an m, so that for all the values bigger than m, all the x is bigger than m, our function values are then going to be bigger than e. Okay, so that is the idea. So here we have what we have to prove. So, as always, let's write out a proof outline before we start writing out our proof. So let's write proof outline. And let me remind you, this is purely mechanical. How do you write your proof outline? You take this statement that you have to prove, and you read it, and you write your proof outline as you go along. So we need to prove something for every epsilon. So what will we do? We will fix any, I said epsilon, I meant e, capital E, bigger than 0. Then we must show that there exists an m, or we must define it. So define m as, and it has to be positive. And what are we allowed to use? We're allowed to use any of our previously defined symbols. We're allowed to use capital E here in defining our m. So that if x is bigger than m, so what will we do? We will assume x is bigger than m, and then we have to conclude, so somehow conclude that f of x is bigger than e. Okay. So here we have our proof outline. So in the next video, we will flesh out our proof outline. I will see you in the next one.